All right, so we're gonna look at hooking up a buzzer here and making sound with it. So this is a graphic of a buzzer. The pins are actually a little more separated than this. So you just want to make sure that when you wire it up, you get the wires in the same row, or yeah, as each of the pins. One side we're going to connect to ground with the resistor. The other side will connect to like a pin. So here we got on pin 16 in the graphic. You can connect to whatever pin you want, but the purpose here is that it's going to, or at least the purpose of this resistor is it will reduce the volume. So, you know, when we have like 30 people buzzing their buzzers all at the same time, we don't lose our sanity. But anyway, so we're going to be controlling this using square waves, the PWM, the pulse width modulation. And so let's take a step back and look at that. All right, so previously we looked at PWM, the pulse width modulation. And so this is an example of, so in pulse width modulation, we control both the frequency and the duty cycle. And so with sound, we want a duty cycle of about 50%. We're going to generate this kind of square wave with a 50% duty cycle. And then by changing the frequency of this PWM signal, like the number of waves per second, we also actually can change the pitch of a speaker if it's connected. And so this is how we can generate a sound. And by adjusting the frequency of these waves, we can change the pitch of that sound. And so it's pretty fun. You can try all kinds of pitches and see what we're capable of hearing and not hearing and stuff like that. And so if we come over to Tani here and we look at writing some code for this, the approach that we're going to take is this. We're going to start by importing the PWM library. All right, and so we're going to say from machine import PWM. All right, we'll make an instance. We'll call it buzzer equals say PWM, and we got on pin 15. We've got, let's see what else, pin 15, and we'll set our starting frequency equal to 0, and our duty U16 to be equal to just didn't make a variable here, so duty cycle on, duty cycle off. So duty cycle off will be 0. So we'll set our starting duty cycle to that. And then for on, it's going to be 65535 divided by 2. Okay, it would be half, right? If 65,535 is our max, we want half of that to get 50%. Okay, and so let me do that calculation. 65535 over 2. All right, so we're going to go 32768. 32768. Okay. I guess technically it would be a integer division. And technically we should round down, but I'm going to round up here. Okay, so we'll start with a frequency of 0. And so we've created our PWM object. And now, if we go to, what we're going to do here, we're going to say try except. The reason we're going to do this is because we want the buzzer to turn off when we're done. Otherwise, we could end up with a situation where it stays on after the program ends, and then we have to figure out how to shut it off. So we're going to set the duty cycle off. Okay. We'll grab the exception here and print it so we know what the error is. But the purpose of doing this is so that when it's done, it kind of cleans up the script and turns this to off. Okay? And so what we'll do is we'll just have a while loop. So while true, and what we're going to do is we're going to just beep the buzzer. So we'll say buzzer dot duty U16, and we're going to set it to duty cycle on, And then we're going to set the frequency. I can probably set the frequency first. Let's set the frequency. Buzzer dot freq equals, we'll start with 500 hertz. And we'll go 512. And so now we just have to change the duty cycle. So we'll say time dot sleep for 1 second. Then we'll turn it off and sleep for 1 more second. There we go. So now what's going to happen is we create our buzzer object, we initialize it to off, we set our frequency, and we have this try except block so that when the script ends, we can clean up by turning this off. And then in this while loop, we're going to turn it on, we're going to wait, we're going to turn it off, and then we're going to wait. And so we can hear it beeping at us when we run it. Frequency is too small. Oh, right here. Probably we can't have a frequency of 0. So we'll just set it right there. Oh, import time. There we go. Alright, and hopefully you hear beeping. Alright, I also had the wrong pin here, so it was okay. So we change this to 16. So I don't know if you can hear it, but mine's beeping right here. If you put your finger over, it gets a little louder. Okay, and there you go. That's how you get the buzzer to beep. All right, one other note here. In our exception, we want to add that extra little delay. So I think to give this time to turn off. Otherwise, it still didn't finish turning off at the end of the script. So in your exception block, make sure you add that short little sleep there.